Well, hi guys, we're having a look at the Victorian Methods Exam 2006 Methods CAS, and it's exam 1, so let's go and have a look at it. Okay, question 1. We've got f of x equals x squared plus 1 and g of x equals 2x plus 1. We have to write down the rule for f of g of x. Now that's a 1 mark question, which means don't do too much. So let's think about that. F of x is x squared plus 1, therefore f of g of x would be g of x squared plus 1, wouldn't it? So that's what I think I would do. Yes, and I wouldn't go simplifying the answer either, because if you simplify it and get it wrong, then you've done your mark. That's enough. You just leave it there, okay? Good, that's that one done. Mr. Box, thank you. Yes, it's a 1 mark question only, so please don't simplify it and make it look pretty. You could shoot yourself in the foot. Now, question 2. For the function f such that all real numbers map to their corresponding real numbers, we've got f of x equals 3e to the 2x minus 1. Find the rule for the inverse function. Now, did you see it says the rule? The rule means you don't need the domain in that part. It looks like they're asking for the domain in part B. Now, you have to set these out correctly. You must set them out correctly. So what I usually, yes, that's the rule. What I usually say is let y, so that I haven't got f of x's worrying me, because I like to swap x and y, okay? It's a bit difficult to swap x and f, if you know what I mean. So, alright, here we go. We need, yeah, it's a one-to-one function, so we need to swap x and y. There it is. Now, all we've got to do now is make y the subject, which means that because y is in the exponent, we've got to take the log of both sides. So, just cleaning that up a little bit, now we're going to zap it with log of both sides. There it is, okay? There it is, guys, and therefore y would be 1/2 of that. Now, not too hard? No, not too hard at all. That's a 2 mark question. There'd be a method mark and there'd be an answer mark for that. But what you have to do, what you must do, ladies and gentlemen, is put it in the proper format here. This format here. Don't leave it as y, because remember, the original question they said f of x. So you've got to make sure you put this step in here, okay? And say f to the minus 1 x, if you like, is that thing, right? You can put a box around it and everything's good. By the way, you should put a box around your answers, because they like to see where the finishing point is in the question. A lot of students just sort of go all over the place, and the examiners can't work out where the answer is. Okay, the domain of the inverse function. Alright, so that'll be the range of the original function. So let's see what was the range of this thing. Well, I think e to the x goes from 0 to infinity, not including 0, doesn't it? Round bracket 0, comma, infinity, close round bracket. So therefore that's going to be the domain of this thing. I would think, yeah, that's the range of the original, and therefore that's the domain of the one we're working with. There it is, okay? Mr. Box, thank you so much. Now, okay, so that's got that one done, okay? Good work, good work. Okay, we're on a roll now, let's keep going. Question 3. Looks like f of x equals e to the cos x. Find f dashed x. Well, that's of the family e to the x, except there's no x there, there's a cos x. So that means we're going to have to chain rule it. Yes? That's a pretty easy question. It's just going to be e to the cos x times minus sine x, guys. Let's see. There it goes. Yeah, there it is, okay? And you might just sort of fix it up a little bit, make it look a little bit nicer, but it's only a 1 mark question, so don't go to town on it. There it is, yeah? That's it. Now, part B, we've got y equals x tan x, evaluate dy dx. Yeah, that's all right. That's just a product rule, isn't it? It's something times something, yes? And do you know the derivative of tan x? Because if you don't, you better work it out before you start the whole thing, because it gets a bit messy. Actually, the derivative of tan x is sec squared x, which is another name for 1 over cos squared x. I just remember that one, because it's nice and quick and easy, and it's not too much trouble for my brain matter, okay? So, here we go. There it is. It's a 3 mark question, so obviously they're expecting to give 3 marks along the way. There'll be an answer mark and probably a method and an answer mark intermediate answer mark or 2 method marks. So there it is, but it's a pretty easy question for 3 marks, I think. There it goes, yes, so I think that's the answer. Oh no, we've got to substitute x is pi on 6 into it, don't we? Okay, so that's where we've got to know what our exact values are, because this is a tech-free exam. Now, cos of pi on 6, come on, what is it? Come on. Yes, did you get it right? Cos of pi on 6 is root 3 on 2, therefore sec of pi on 6 would have to be 2 over root 3, and sec squared would be 4 over 3, wouldn't it? Tan of pi on 6 is 1 over root 3. Now you have to know those. Please do yourself a favour and learn them off by heart so that you're lightning fast. There it goes. There we go. Yeah. Yeah, and that's, we'll just clean that up a little bit. It is a 3 mark question. That looks pretty good. So it looks like it's, that 4 and the 6, or 2 will go into each of those. So it'll be 2 pi over 9, 2 pi over 9 plus 1 over root 3. And I think a box, oh no, one more line. And that looks like, yeah, that'll do. Oh, goodness, what have I done? All right, I've put it over all over 9. Okay, now, Mr. Box, thank you, Mr. Box. Okay, you're right with that now? Good work. Okay, so that's question 3 done. So far, not looking too shabby, guys. I think it looks good, don't you? Question 4, okay? Okay, it looks like we've got a trig function here. What have we got? From minus pi to pi, x goes from minus pi to pi. We've got f of x equals 5 cos of 2 into x plus pi on 3. Right, well that's an interesting looking beast, isn't it? We've got to write down the amplitude and the period. Looks like 1 mark each. Well, that's pretty easy. They're easy marks, guys. The amplitude is 5 and the period is what? Come on. What is it? It's 2 pi over whatever that number is there, okay? That number is a 2, so it's 2 pi over 2, which means it's pi, isn't it? Yeah, that's 5. It means it goes up 5 and down 5 from the central axis, yes? And the period is 2 pi over 2, which is pi. There's 2 easy marks for you, okay? Excellent job. Now, oh no, we've got to sketch the dreaded graph of the thing on the set of axes below. Label the axes intercepts with their coordinates, label endpoints of the graph with their, oh goodness. And this is a 3 mark question. Look, do you know what, ladies and gentlemen, there's hardly any room on the exam paper for any working with this question. I think it's a disaster for 3 marks, to be perfectly honest. And they're so time consuming, I would just put a circle around that one and I would keep going and I would do the rest of the paper first. Trig graphs are notoriously time consuming. The only saving grace of this thing is that it is only translated horizontally in the x direction. It's not vertically translated up. So that means, the saving grace means that the x-intercepts will be the same distance apart as the original, say, sine of 2x function without the 2 bracket x plus pi on 3. They'll be the x-intercepts will be the same distance apart. They'll just be shuffled all over to the left by pi on 3. That's what it means. So you can work out what the original ones for cos 2x would have been if you like, and then you can just shuffle them all over by negative pi on 3 or pi on 3 to the left. Yes? So you've got to use the information that you used in part A as well. That's why they asked you for that. The amplitude is 5. Okay, that means it's going to go up to 5 from the central axis, which is the x-axis, and it's going to go down 5. And the whole thing shuffled, as I said, over to the left by pi on 3, and it's also got a period of pi, right? So, yeah, it's a beast. I know. So, look, I'll just go through the motions, but, you know, if I was you, I would be leaving it till the end, I can tell you. So, alright, so write in pencil. That's the very first thing. Do not write in pen for graphs. If you mess it up, you can't rub it out. It's an absolute death trap, you know. You'll get all psychologically all stirred up and nervous and messed up because you won't know where to go if you've ruined your sketching area, you know, by making a mistake. So do it in pencil. Then if you want to, you can write over it in pen, but don't write in pen in the first place. Yes. Now we need the x-intercepts, we need the y-intercept, we need the starting point, for cos, which normally for cos would be, if it wasn't stretched vertically, then it was just a normal old y equals cos x graph, it'd be normally starting at x is 0 and y is 1, wouldn't it? Well, I'm going to work out the new starting point for it, okay? And I also work out what I call the quarter cycle shift, which is very, very useful when you're doing cos and sine graphs. Yes, I step through the graph in quarter cycle bursts. So I work out, in this case, that's going to be pi on 4, yes, because the whole thing has a period of pi. And the endpoints. All that stuff's got to be done for a 3 jolly mark question. It's a bit rough, in my humble opinion. Now, let's go. I think I needed to go over the page. So let's do the x-intercepts. Here we go, guys. Now, for y equals cos x, okay, if you think about, normally if you think about y equals cos x, not 2x, your first intercept going right from the origin in the positive x direction would be pi on 2, and then it would be every pi after that, right? Well, this is going to be scrunched up into half of its normal space, so it'll be pi on 4 and every pi on 2 after that. So, right? So that's what you would basically use that information. It's moved to the left by pi on 3, so we would therefore we're starting at minus pi on 12 and then every pi on 2, which is 6 pi on 12. Is that right? Yeah, that's right, because if the first intercept is normally going to be at pi on 4 and we're moving everything to the left by pi on 3, which is 4 pi on 12, that means our first intercept is going to be at minus pi on 12, if you like, and then we're moving every 6 pi on 12 forwards and backwards from there. Okay, that's how to work it out. Nice and simple, isn't it? So there it goes. Yeah, there they go. They're the forwards ones, yeah. And that one's out of range because we're only allowed to go up to pi, aren't we? And backwards, we're going to go backwards like that. Yeah, got it? Yeah. Okay, now, I think that last one is a lot of range too. Yes, because we're only allowed to go from minus pi to pi. So there's our intercepts. Now, that was nice and easy, wasn't it, guys? It was. So that's the best way to do those. I think the quick way, you know, the quick and dirty way, well, it's not the dirty way, it's the great way. Now here comes the y-intercept, that's when x equals 0, so you just plug x as 0 into it, and you get that. Now, we're going to work out what cos 2 pi on 3 is. Well, we know what cos pi on 3 is, that's a half, and 2 pi on 3 is going to be negative a half, isn't it? So therefore it looks like minus 5 on 2, I think. Get it? Yes, good show. Now we've got that done. Okay, so that's the x-intercept and the y-intercept. Right. That's it. That's your y-intercept. Yes, thank you, Mr. Box. Now, what else have we got to do? We've got to do the starting point. Okay, so that's when the thing behind the cos sign equals 0, right? Normally where you start is when x is 0. So now the way we do it with this transformed beastie of a function, we say the whole thing behind the cos symbol is 0, and therefore what is x going to be? We solve it for x. So x is minus pi on 3. So that's good. That means that the starting point is going to be x is minus pi on 3, and I would think y would be where? The top of the heap. That's where cos starts. It would be at 5, wouldn't it? Yes, very good, very good. Now, okay, here comes our quarter cycle shift. Isn't this boring? This is terrible, isn't it? I hope they don't give one to students ever again. But they did in 2006. So quarter cycle shift, well, you know, the period is pi, so a quarter cycle shift is going to be a quarter of pi, or I think we have to deal in 12ths with this beast because everything's sort of, it's moved by pi on 3, isn't it? No, pi on 6, isn't it? Yeah, so I think I can see a common denominator of a 12th happening here anyway. Quarter of cycle shift is pi on 4, which is 3 pi on 12, yes. And the endpoints, I think that's the last of the things we have to work out, isn't it? So that's just substituting x as pi and x as minus pi into the equation to get y. And what do we get? Yes, yes, and what does it come out to be? Oh, good. It's the same as what we got for the y-intercept, yeah? And that'll be the same thing for for when x equals plus pi. It's the same thing. Yeah, it works out to be the same thing. Yeah, good. Good, good, good. Now, what else have we got to do? Oh, goodness. Yes, yeah. Oh, here we go. Here we go. We're going to do it now, guys. Here's the starting point, right? Starting point was, now what was it again? It was minus pi on 3, which is 4 pi on 12, isn't it? Yeah. And 5. Y is 5. Now, I'm going to put in my extremes. There's my, oh, what's that? That's the next quarter cycle. That's the next quarter cycle. See, I'm stepping it off in quarter cycle shifts, which are 3 pi on 12ths, yeah? Now, all I've got to do for the next quarter cycle is go along 3 pi on 12 and then down to minus 5. See? How easy is it? Get it? Go along another 3, 3 graduations and go back to the central axis again. See, you just keep doing that now. It's easy, isn't it? Then you just got to put your do the same thing going backwards, and and now I'm stepping it out in quarter cycle shifts. Do you see? Do you see? Isn't it terrific? Yeah, see, that's how I do it, and it's so easy to do. And your graph looks half decent when you do it that way. And there's your end point there, okay, which is going to be whatever it was, minus 2.5. Yeah, that's right. Good, good, good. And there's your other end point, yeah? Now you've got to put the label everything like there's no tomorrow, okay? Everything gets labelled, all the intercepts, all the end points, the whole shooting match. Y-intercept, yes, I think that might be the end of the beastly thing. Yeah, good riddance. Sorry, Mr. Trig function, it's not your fault. It's just a silly thing to put into an exam, I think, for 3 marks. So, alright, so what do we got now, guys? We've got x is a normally distributed random variable, the mean of 72, standard deviation of 8. Let x be the standard normal variable. Use the result that the probability that z is less than 1 is 0.84. Correct the two decimal places to find the probability that x is going to be greater than 8. What is it? Greater than... I can't read it. Greater than 80. Okay, good, 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 good. Well, this is not a really bad question. It's only worth 1 mark. So I always draw a diagram just to get my head straight. So we're dealing with 1 standard deviation. That's the key here. So they're saying that when, the probability that z is less than 1, that's the standard normal curve, is 0.84. Therefore, the probability that z is going to be more than 1 would be 0.16, wouldn't it? Now, I think that's what we're talking about in this the other scenario of the actual case of the normal distribution where we've got a mean of 72 and a standard deviation of 8. So they're asking us for the probability that x will be greater than 1 standard deviation to the right of the mean. Yes, so I think it's got to be 0.16, doesn't it? Yes, very nice. So there you go. Yeah, 80 is 1 standard deviation above the mean of 72. And therefore, excellent. Well, that's not a bad question, is it, for 1 mark? But look how useful it is to draw a diagram. I know. It's only a 1 mark question, but look, if you want to save your brain power, and cut through all the riddles that they throw at you, a diagram is just the most visual, wonderful thing that you do. I love diagrams. Hope you do too. Yeah, it's only worth 1 mark, so you only need an answer. Yeah. Okay, now we're going to work out that the probability that x is going to be between 64 and 72. Again, I think a diagram is a great thing. It's only a 1 mark question, so it's not meant to be very hard. But a diagram will always save your life, I think. It'll tell you what we're supposed to be doing here. So it's got a mean of 72 standard deviation. So we're looking for the probability that we're between 64 and 72. Yeah, that's 1 standard deviation from the mean to 1 standard deviation to the left of the mean. Now, guys, I hope you've remembered your 68, 95, 99.7 rule, because you're going to need it. Okay, yeah. Oh, yeah, that's right. Well, you can also do it that way. That's right. That's 0.16, is it? Oh, yeah, that's right. 0.16, and therefore that one there is going to be 0.34. Yeah, well, the way I said in the first place is perfectly valid anyway, because one standard deviation either side of the mean is 68, isn't it? 68, that's right. 68, then 95 for two standard deviations, then 99.7. So that's all right. Either is fine, okay? Yeah, either is fine. So the way I've done it in the question there is I've just said that was, if you're going to go one standard deviation to the left, or everything up to, but not up to there, from the left, from minus infinity to there, you're going to get 0.16 because of the symmetry with this diagram up here. And therefore this one's going to be 0.34 because the whole thing up to the halfway point must add up to 0.5. Well, that's alright, isn't it? No problem. Diagram saves the day. Diagram saves the day. Thank you, Mr. Box. Okay, now what's this? The probability that x is less than 64 given that x is going to be less than 72. Well, that's just a straight conditional probability question, guys. Now you can do that. Someone's standing on your head. So the probability that x is less than 64 given that it's less than 72 is equal to the probability da-da-da-da, like I've written. Yes, now, if you look at the top line, probability that x is less than 64 and is less than 72. Well, if you just do the less than 64, that covers both of them, doesn't it? It does. Yeah, okay, so that's all you've got to do. Now you can just look those up directly from the previous answers and you get that. Yes, you do, okay, which is going to be 0.34. Yeah. Yeah. 0.32, I mean, not 0.34, 2 16s are 32. 8 over 25 will do it. You do have to do an exact answer, but you haven't got your calculator anyway, so that won't be much of a problem. Alright, so let's keep going. The probability density function of a continuous random variable x is given by that thing. Find that this is a continuous one now. Continuous, guys. We've got to find the probability that x is less than 3. Well, it looks like from our situation up here that x is allowed to go from 1 to 5. So we'll just do the what is it, pi on 12? It's just pi on 12, is it? Wait a minute, I'm going to look at this. X on 12. I'm sorry, I can't see properly. X on 12. So we've just got to do a straight integral of this thing, or we could even do a little triangle thing if we wanted to, but this will do. Yeah, x over 12 dx from 1 to 3 gets x squared over 24 from 1 to 3, and that gets us whatever it gets us. Looks like it gets us a third. For 2 marks, that's a nice easy question, isn't it? Very easy, okay? No problem? Yeah, how are you feeling, alright? Good, let's keep going. The probability density function of a continuous business part B. Now we're going to find that if the probability that x is greater than or equal to a is 5/8, we've got to find the value of a, okay? Well, yeah, there's just several ways to do that. It's just a straight little area thing. So I've just said there from a to 5, the integral from a to 5 is equal to 5/8, and then you've just got to solve it as a definite integral. And how does that go? Substituting in your terminals, that's what you get. Okay, you see that? And now just sort of making it a bit easier to solve, lowest common denominator and all that. Therefore it looks like 25 minus a squared equals 15, therefore a squared is going to be 10, and therefore a is going to be, now this is where the kicker is, guys. This is where the kicker is. They're saying here probability that x is greater than a, right? X is greater than or equal to a. Now a can only go from 1 to 5, can't it? So it can't be negative. That's the thing. So you've got to be on the alert. Therefore a is going to be root 10. Okay, we have to reject the negative answer. Thank you, Mr. Box. Okay, you're right? Good, good, good. Question 7. What is this thing? We've got a function going from -5 to 1. in the domain mapping to their real counterparts, where f of x is equal to x cubed plus 6x squared plus 9x. Alright, it's a cubic, and a mighty fine looking cubic too. On the same axis we have to sketch in part A the graph of the modulus. Well, that's, goodness, that's nice and easy, isn't it? Yes, do you know how to do that? Of course you do. It's just whatever is negative, you just make it positive, reflected about the x-axis. There it is. There it is. Yeah? Well, there's an easy... That was worth 2 marks. Goodness. They're the easiest marks I've ever seen. Okay, now, what are we going to do now? In part B, we're going to state the range of the function with the rule y equals modulus of x and domain. So the range of the function, okay? How do you think you might do that, guys? Well, I think that what you've got to do there, see, the range is from the lowest to the highest. Well, it seems to me pretty obvious that the lowest is 0. Wouldn't you agree with that? Of that red graph you can see there. Now the highest will really depend on what the end point values of y are, I think. So I think I'd work out y for -5, again for 1, and then I'd see which of those is higher. Let's have a go at that, will we? So it looks like f of -5 is, working it all out, remember this is a tech-free exam, so just play it cool and you won't go wrong. Don't be an algebra hero. Please don't be an algebra hero by doing too much at once. It's -20. Okay, so that's f of -5. So therefore, modulus of that would be +20, wouldn't it? Yeah? Now f of 1 is all of that, and that's going to be, looks like it's going to be 16. So look, guys, so the modulus of f of x at -5 will be +20, and the modulus at 1 will be the same as just f of 1, which is 16. So I'm backing, the horse I'm backing is range from 0 to 20, I reckon. Don't you? Oh, look at that. Looks like I'm right. You beauty. Okay? Thank you, Mr. Box. Yes? Alright, that's question 7 done. Alright, we're going very well here. Let's just keep going. Now, what's this question 8 saying? Well, these things kind of do your head in a bit, but I'm noticing it's worth 4 marks. That's huge. So come on, you have to read the question a few times to sort of get a starting point, to know what to do. Now, they're telling us that the normal, not the gradient, but the normal to the graph of y equals root x has equation y equals -4x plus a, where a is a real constant. We've got to find the value of a. Well, goodness. So really, we've got to work out what the equation of this normal is, right? We've got to work out what the equation of the normal is. That'll give us a. I think, look, if you're not sure where to start, you just put one foot in front of the other. But the thing, and before you know, the way forward will become much clearer to you as you go. But I'm looking at the equation of the graph, y equals root x. So that I can immediately get a gradient function for that, which will be a half of x to the minus a half, right? Now, if the equation of the normal has a gradient of -4, therefore the gradient of the tangent will be plus 1/4. So if I say then, having just worked out the gradient function as a half of x to the minus a half, if I equate that to be +4, I can get the x value out of it, can't I? I can solve it for x, yeah? If I can solve it for x, then I can plug the value of x in to get y from the original function, right? That's the second step. Now, if I've got that, okay, I can then work from there to plug in the y and the x in the normal equation to get a, I think. Let's just go, and we'll just go with it and see where we go. Okay. Alright, so therefore, yeah, we need x and y. We need x and y to get a. That's right. That's what we have to do. Okay? Now, does that sound reasonable? Let's go for it. So therefore, we've got dy dx is a half of x to the minus a half. Yes, isn't it? Good. Now, the gradient of, as I said in the introduction to it, was the normal is minus 4, therefore the gradient of the actual tangent is going to be, or the function itself is going to be plus a quarter. Now we're cooking along nicely now. We can equate that, put that plus a quarter into the gradient equation which we've just got up there, and we can solve it for x, you see, right? Therefore, yes, very good, therefore x is going to be 4. Now we're getting somewhere. Now if I plug that x as 4 into the original y equals root x equation, I can get y equals 2. Yes! Now I've got x and y, okay, into the normal thingy, and I can solve it for a, okay? Yeah, that's right, the normal passes through 4 and 2, you see, because the normal passes through the same point on the curve that we were talking about, because it is the normal to the curve, yeah? So here we go, we sub those points in, and yes, well it's actually A, it's not C, but that'll do. Yes, and therefore C is 18, that's the same as A. A is 18, okay? Now for 4 marks, look, you know, even if you just made a start and got a couple of things done with that question, and then just sort of didn't get anywhere else, you're likely to pick up a couple of marks along the way. So just make a start and get somewhere. That's the thing, okay? A is 18, thank you, Mr. Box. Now what's this thing? We've got a rectangle. X, Y, Z, W has two vertices, X and W, and two other vertices, Y and Z, are on the graph. So let's have a look at that thing. Oh yeah, it looks pretty normal, and looks like the function is y minus 3x squared as shown in the diagram below. The coordinates of Z, what are they? Oh yeah, okay, Z's here. A and B, but as we know, guys, they are A and 9 minus 3A squared, because that's the equation. Come on, so you don't even need the B, guys. So, you know, we get rid of complication as quick as we can. And A and B are positive real numbers. Yeah, goody, goody. We have to find the area of the... the area of the rectangle in terms of A. Oh, that's pretty easy. That's just the area of the rectangle is the height times the width. Well, it looks to me like the width is 2A, doesn't it? Isn't it? Because it's going either side of the y-axis, and the B thing is 9 minus 3A squared, isn't it? So I think it's already ours. I think we've defeated it before we put pen to paper. Goodness me, we're cooking very well, sizzling in fact. So there you go. Yeah, that's what I was saying. So that's, how many marks is that? Well, it's only worth 1 mark. I got a bit too excited, guys. There it is. There's the area, but there must be something else coming. Let's go over the page and gulp with trepidation and see what they've got for us there. Oh no, this is alright. It's just B. This is part B, same diagram, and then part B says find the maximum value of A and the value of little a for which this occurs. This is just a straight good old friendly calculus question. No problem. So we've got the expression for A, haven't we? So if we do d big A, d little a, and then set it equal to 0, we can get the value of little a and therefore plug it in to get the value of big A, which would be the maximum, wouldn't it? Yes, I believe so. So how many marks is that? 3 marks. Goodness. 3 nice marks too. So there it goes. We solve that. What do we get? Oh, goodness. Looks like A is going to be plus or minus 1 to me. Yes. Most excellent. Now, but they did say that A was... wait a minute. Didn't they say that A was... A was a positive real number. So we've really got to say that A equals 1, don't we? I think so. Yes, just preempting myself there. Yeah, so A is 1. So now, what is the question asking? Go back and reread the question. What do we want? The maximum area A and the value of A of which this occurs. So the value of A is 1. Now we've just got to plug that into the formula for A, and we've got our 3 marks today. Hooray. So there's little a. A max is that thing, which looks to be 12 square units. 3 marks in the bag, guys. 3 marks in the bag for you and me. Ain't it grand? Yes, it is. Now, what's this last thing that they're going to throw at us? Well, it's worth 3 marks, and it looks like some, what are we talking, tea or coffee here? Looks like tea one morning, probability the next morning tea is 0.4. Coffee one morning, the probability that she has coffee the next morning is 0.3. Suppose she has coffee on Monday morning, what is the probability that she has tea on the following Wednesday morning? Look, guys, this is a conditional probability thing. It's obvious. Now, it's a Markov chain thingy, but in exam 1, you please do not do matrices. Just do a tree diagram. You'll save yourself a lot of grief, I'm telling you. Alright, so I think we probably need a tree diagram for this. It's going to be so easy too. It's only, how many transitions have we got? She had coffee on Monday morning. We're only doing 2 transitions. It's ideal for a tree diagram, no problem. So, here we go. Monday, Tuesday, Wednesday. And what are we doing? So tea and not tea, right? She had, because I'm a tea drinker, I don't like talking about coffee, so we'll say tea or not tea. Right, that's Tuesday, and then, now we're putting the numbers in now. That's a 0.3, wasn't it? Yeah, if she, what was it saying? If she has coffee one morning, the probability that she has coffee the next morning is 0.3. So that's not tea given not tea. That's all right. So therefore the one above must be 0.7 because they have to add up to 1, don't they? Let's do the next bit now. And we can fill in the numbers. And yeah, so that's going to be 0.3 again and 0.7. Now, this other one was, what was it again? Yeah, if she had tea one morning, the probability she was going to have tea the next morning was 0.4. So that one's a 0.4. That one has to be 0.6. Now, what have we got to work out? The probability that she has tea on the following Wednesday morning. So that's going to be this one or this one, right? So you just got to work out the probabilities, add them up, and Bob's your uncle. And it looks like 0.28 plus 0.21, which would be 0.49, I think. Yes. Yes. Quick. Yes. Excellent for 3 marks. How do you like that? So good, isn't it? That's great, isn't it? Oh, no, there's another one. Oh, I thought we'd finished. Oh, well. Well, it looks like a calculus-y thing to me, guys, from the probability to the calculus. I've got the graph of f of x is minus x squared, it's an upside-down quadratic, plus a times x plus 12. Looks like we have to probably find a or something. Shown below, if the shaded area is 45 square units, find the value of a, m, and n. Goodness. Oh, m and n, they're the intercepts. Alright, okay, I get this. Where, m and n are the x-intercepts of the graph. Now, what are we supposed to be doing here? Let's see. If the area is 45 square units, oh, I see. Well, area is 40. Why don't we just work out the area as an integral from what are we doing? From 0 to 3. Yeah, from 0 to 3. And then we'll be able to work out a, won't we? Because it has to equal 45 square units. Once we work out a, we'll have the whole quadratic revealed to us, in which case we should be able to work out where its x-intercepts are. That's worth 5 marks. Gee, I reckon that's not very hard for 5 marks. So let's go and get those 5 marks. Right, so there we go. Do you get my game plan? I think that's the way to go, don't you? Area, integral. There it is. That equals 45. Yeah? Now, just integrating, that's pretty easy. Yeah, and right, that comes to 45. So I'm equating it equal to 45. Just being careful not to be an algebra here and mess it up. Don't do that. That's very, very unfortunate. Not at this stage, not at question 11. Okay, so off we go. It's working out very nicely. Looks like 45 equals that thing. And, yeah, A is going to be easy to work out. So there it is, and there it is. Where do we got? Let me see. Yes. Yes, that looks right to me. Yes, good. So therefore, what's A going to be? It looks like it's going to be 4. Yeah, there it goes. There you go. A is 4. Oh, beautiful. So therefore, what's our quadratic here now? Let's just see. Okay, and we've got to work out what the intercepts are. Well, I can smell it straight off. The factors of 12 are 6 and 2, and you can get a 4 out of the middle term from a 6 and a 2, can't you? I think so. I think so. Let's do it. There it is, yeah, there it is, and told you. Here it is. There it is. So therefore, our intercepts are -2 and +6. So therefore, it looks like n is -2 and m is +6. Get them in the right order. Don't mess that up now that we've gone this far. Yeah. Yes, A is 4, M is +6, N is -2, and Bob's our uncle, and thank you, Mr. Box. Now, I think, hopefully, that's the end. Is that the end? Oh, thank goodness. So, all right. How did you enjoy that? Now, it wasn't too hard. You'd probably have to go back at this point and fix that trig graph up, you know, because that's the thing I think I'll be leaving till last. It's too tedious altogether for 3 marks. They hardly give you any room to work it out, which I think is quite ridiculous, but I better not be too critical. And thank you so much for listening, and I hope it was of benefit for you. Okay? Bye-bye.